Hello, I'm David Wasson with CAPS, manufacturer of the Herc Rentals 200-ton air-cooled water chiller. This short video is going to go through the setup, installation, and operation of this air-cooled chiller for both comfort cooling and process installation. The first step in setting up the 200-ton air-cooled chiller is to determine how it's going to be transported. You have two options to transport the machine. The first is a set of integrated fork pockets here at the base of the skid. The second option is we have an overhead lifting certified stacking cage. Each corner has got a lifting pad eyelet there. The machine can be lifted in a single point lift from all four corners. All the bracing is necessary in here to have the certification. So the machine can be moved with either a crane or a forklift. Please note that the weight of the machines is always located on the stainless steel tag at the bottom corner. This particular machine weighs 20,000 pounds, so the proper crane or forklift will be necessary in mobilizing and setting the chiller on a particular job site. Please note that when you do set the machine on the job site, that you need to make sure that it's on a level, stable ground that can hold the 20,000 pounds of weight. For safety, the machine is marked clearly with the center of gravity on all four sides. That's going to be necessary for lifting it overhead with cranes or with a pick truck. The next step in our setup is going to be to verify the power requirements. The MCA, or minimum circuit ampacity, required to run the entire assembly with the integrated pump is clearly labeled here on the CAPS data tag. This particular machine takes 379 amps of power, and the MOCP, or maximum overcurrent protection, is 450 amps. We also have clearly identified a lifting diagram here beside the panel, and both the main chiller has an integrated circuit breaker in it as well as the pump. So all of our internal electrical components of the machine are protected by high voltage line sized breakers. You'll only have to protect the cable coming to the machine either from a generator or from the permanent power source. Okay, now that we've verified our power requirements being 379 amps, it's time to hook up our main Camlock Power. Now please note that on the 200-ton chiller, it requires a parallel feed. Each one of the number 4 DLOs are rated for 400 amps. A lot of the plants derate these by 20%, which would only give us 320 amps. So we've designed the chiller to have a set of parallel Camlocks in here, which requires a double feed in order to meet the plant requirements. So I'm going to start by removing the dust caps and the moisture shields here off the Camlocks. And you'll notice we've got two sets. They're back to back and they are offset, so it makes it easier to be able to hook them up. We're going to hook up the first set of Camlocks, and you're always going to hook up your ground first. That's for safety. We're going to go to the back set here, and we're going to hook up the ground first, and then proceed with L1, L2, and L3. Okay, we've completed hooking up both sets, so we're in a full parallel configuration here with L1, 2, 3, and our grounds here. The next step is going to be for us to energize the power. We've removed our lockout tag out from our permanent power source, so the Camlocks are hot now, they are energized. We're simply going to take the main circuit breaker here on the chiller, and we're going to roll it around and turn it on. And you notice that we've got a power light here, but we also have a phase incorrect light. That indicates that two of our phases are backwards, they're out of phase. There's a phase monitor inside the machine that prevents it from starting in reverse rotation. So we'll need to first turn the power off here at the chiller. We'll lock and tag out our power at our permanent power source, and we're going to have to swap two of our phases, A and B phase. Please note that you never change the Camlocks while the cable is energized. Okay, we've reversed phase A and B as indicated here with L1 and L2. We've removed our lockout tag out from our permanent power source. Our cables are now energized. We're going to go up and turn the main power disconnect back on again. Now we have a power light and our phase incorrect light is off. So now we're powered up and ready to go. Inside this pump panel is a lockout timer for this chiller. The purpose of that lockout timer is to have the 460 volt applied to the machine, lock it out for 1 hour to allow the compressor crankcases to heat up heat the oil up, removing the refrigerant that might be inside the compressor so that we don't have a cold start. And that lockout timer will prevent the machine from running. We always hook the power up to the machine first so that we can start the timer and get past that 1 hour lapse portion until we do our plumbing and our air handler and the other parts of the job that are required for a particular application. In order to start that timer though, we'll have to go to the main system switch here and turn it on. Notice that our pump switch is off and our pump breaker is off. At this point, all we're doing is warming the compressor up while we're continuing with the rest of our setup. Okay, the next step is I want to go over some of our pump and our hydronic side of the system on our chiller. All of the Herc Reynolds 200-ton chillers have an integrated circulating pump built into the machine. Here's our inlet here. It's going to be our inlet to our warm water that comes into the machine. This is a Y strainer here. It's got a basket inside there. It'll catch heavy debris. That's in there to protect the pump and to protect the heat exchanger. At the bottom of it here, there's a blowdown valve, and that valve can be opened to knock any trash or debris out after a startup or to verify there's no foreign matter inside the basket. So as our flow comes in here, goes through the strainer, comes out, then we've got to make a decision here. Since we have an integrated pump here, we can operate the machine off our pump, but if our customer has their own pump and doesn't want to use our pump, it's very simple. It's just a matter of closing the inlet valve going into our pump, and then we're going to open the valve going into our bypass there. So now the water flow will come in. It won't go through the pump, but it will bypass the pump and go through the heat exchanger. If we're going to use the pump in an installation, we just simply reverse that by closing the bypass and opening up the pump valve there. A few other items I want to point out here is the main bottom drain for winterization is right here under the bottom of the volute of the pump. There's a ball valve there that you can drain the water out of the pump casting during winterization or cold storage. And then the last item is right here is a T-valve at the top. We're going to open that up to bleed air out of the pump so we get a good prime on the pump itself. So your decisions here are just going to be to ask the client if we're going to use our pump on board to circulate water through the process or the comfort cooling application, or if we're going to block ours out and use their pump. Both are acceptable as long as it's sized for the size of the 200-ton machine. Okay, now that we're getting ready to plumb the system, let's go over a little bit more of the connections and the gauges and instrumentation that we've built into the machine. First of all, the female 4-inch Camlock is the inlet, and that's our inlet into our pump or to our loop off our customer supply line. It's going to come off the pump and go through this pipe here through the heat exchanger. Over here, notice that we've got a compound gauge here to read our pressure, what's going into the heat exchanger. We also have a manual thermometer here as well and a test port. The water's going to go in through the heat exchanger, and this is our outlet here. Main outlet, it's got a male Camlock on this, so this is going to be our cold water going to our air handler or to our process chilling application. This is our balancing valve here. This is where we're going to regulate flow. If we need less, we'll be closing it. If we need more, we'll be opening it up. We also have compound gauge here as well as another thermometer here on this side, and this will handle us as far as our setup for balancing the water. The last item I want to cover while we're here in this shot is going to be this is our differential pressure switch, or better yet known as our flow switch. There's a hose going across the low side of the barrel and the high side of the barrel. As long as there's differential pressure, meaning full water flow across the heat exchanger, that creates a pressure differential that makes the switch that proves and tells the chiller, I have flow, I'm safe to run. Anytime that we lose water, have air in the system, or any type of abnormality during the setup, if you have that process, we do not have differential pressure across there, this switch is a lifesaver and will shut down the chiller and await for a service call. Okay, we've hooked up our 4-inch quick connects on both for the inlet and outlet of the chilled water flow. Now it's time for us to hook up our fill line. This is a 3/4-inch garden hose connection. We're going to hook it up to the valve here that has the check valve in line right there. This is a ball valve. Now we've got the water on here. We're simply going to turn the water on, and we'll be filling our system here. This is the drain valve over here. We'll be using that when we take the chiller and remove it off the site. We'll use that as our low point drain. But as we fill the system up, we're filling from the bottom of the barrel with the vent line open. There's a high point vent that's opening, and we're filling from the bottom to push the water up and push the air out. And that's the whole point of us filling from the bottom of the barrel, to get the air out of the system. You know, you can't have any air in the system when you have a chiller because you can't have any heat transfer. Okay, we've got our system completely filled now. We're at about 45 psi according to our gauge here, which is fine. 40 to 55, 60 psi is a good starting point. We've already circulated the water through our hoses, our air handler, and our pump, and it went through a process of bleeding air. Every time we turn our pump on, we stir the water through the system. All the water falls down, all the air goes up, and we go to our high points and bleed out the air. So your high point's going to be on the chiller. There's a high point bleed on the other side, clearly labeled. You open it up and that'll pull the air off the top of the heat exchanger. Okay, we've cycled our pump several times as we filled it up. And this is clearly labeled high point bleed. It's opposite side of the fill line. If you open this valve here, it's plumbed to the top of the heat exchanger, and you'll hear immediately that we have air there. I'm demonstrating that as the water's going in, the air pushes out. After just a few seconds, you'll see we had just a little bit of air left in there, but now we've got a full stream of water coming out. Once we get it completely full flowing water, all of our air is out of the system. Then your second high point is going to be your air unit if you're using one of the matching chill water air handling units. There's an air vent at the top of those. You'll continue that process until you get all the air out of the system. Please note that if you don't have the air out of the system, you're not going to have a median or the water to be able to do your heat absorption and exchange through the chiller. The purpose of the chiller is to chill the water to circulate through the air handler or through the process application to gather heat, bring the heat back with the water to the chiller, where the chiller now removes that heat. So now that we're through that process, we're going to go up to the pump panel and show you how to get the pump started. Okay, to start our pump, we're simply just going to close the main pump breaker, which is located right here, pump disconnect. That'll send the 460 volt to our motor controls inside. Then we've got a simple pump switch here that says off and then on. By turning it on, you can hear the pump come on and run and back off. Back on and off. Now what you want to remember is you can never get the air out of the system as long as the pump is running. So you want to go through a cycle as you're filling the system and going to your high points. You'll want to turn that on for 3 or 4 seconds, stir the water up. Then when you turn it off, all the water will fall, all the air will go up, and that'll allow you to bleed the air off of the system. Okay, just to recap the installation of the 200-ton air-cooled chiller, we verified our power requirements and have enough power coming to the machine, which is 379 amps. We've set the machine on a good stable ground using a forklift. We've plumbed in the system with 4-inch Camlock fittings. We filled the system completely up with water, bled the air out of the system. We've cycled our pump several times to allow for that to stir the water out, push the air to the high points, water down the low points there. Now we're fully got all the air out. We're fully pressurized at a standing pressure of about 50 psi. We've had our power on for about an hour and a half, so our crankcase heater timer is timed out. The compressors are now safe to start, so we don't need our PPE hot gloves anymore. From now, we're going to go through the control panel. We've got our pump currently on, main power's on, our pump's running, master switch is on, power's on, phase is correct. Now we're ready to go through the control panel and set the chiller up into permanent operation. Okay, we're going to first start by opening up the control panel door here. And you'll notice that, first of all, our keypad in here, this is our status screen, our LCD screen here. At any time tells you values of the chiller, what the chiller's doing, the operation. It's basically your user interface. So I'm going to take a moment to go quickly down through the buttons here. First off, don't worry about pushing any of the buttons and hurting anything, because you're not going to. You just go back to your main status, and it tells you right now that the unit status, unit switch is in the off position. That's this switch here. That's that unit switch. So let me run through the buttons. The status is your home screen. The unit data is a very commonly used button. You push it to determine what your water temperatures are. And right now you'll see we've got leading water temperature of 84.5, entering 84.5. That's a good troubleshooting point there to note that both sensors are reading the same value, indicates both of them are in a healthy state, because we don't have the the chiller running right now. Once you're into the user data menu, you can simply just arrow down. That'll tell you the ambient temperature is about 91 degrees out here. That'll tell you your system number, your pump is running. Again, this is just data here, nothing to change. Same thing with system 1. If I go to system 1, that's going to tell you my refrigerant pressures, being suction pressure, discharge pressure, all of my temperatures, superheat, subcooling, all the technical data associated with system 1. This being a 200-ton chiller, it's got 2 circuits on it, system 1 and system 2. Each one of them are 100 tons, so you're going to have data underneath system number 2. System 3 and 4 for larger tonnage chillers, so when you push those buttons, there's no data available because it doesn't require a 3rd and 4th compressor there. The VSD data is your variable speed drive data, and then this is where your hertz are going up and down as it's commanded off the variable speed drive. This machine does run completely off variable speed drives, allow for infinite temperature control. Then you've got your operating hour and start counters. All that does is count how many times the machine started and stopped, how many hours the compressors have ran. The history button is very important for troubleshooting. If you push the history button and there should be a fault or a failure there, in that case you can simply just go into the safety shutdowns. You go right and left on it and you go enter in there, and it'll tell you that there's no faults because it's a brand new machine. There's never been any faults in it. But should you have a fault, you would go to your history button, and that would certainly tell you where that information is. Again, the whole left-hand side of the keypad is nothing more than data. This keypad here is just a numeric keypad for entering values. The check mark is your enter button. The X is your delete button. Up and down navigates through menus, right and left, change values here. And then on your right side, the most commonly used button is going to be your set point. So if you push your set point, you'll note that this is set up for comfort cooling. It says a low of 40 degrees, a high of 70. It's currently set at 44 degrees. We want to chill the water down to 44. And that's the only thing we have the set point. If you ever get lost, just go back to status. You can go back to set point, and we're going to change the set point to 42. You just simply enter 42, push the check button, that locks it in, and now you're done. You can go back to status. And the program button, if you push the program, it says press enter. After you do that, this is where our low pressure settings are, high pressure settings. This information is pretty well all set up from the factory here at CAPS when they ship the machine out. But from time to time, there will be some adjustments needed in there, and that'll come to our advanced class. We go back to status, and here's another one, options. Again, this is where we can change the language. We can change whether it's a water cooler or a glycol chiller. This is where we change out remote control, imperial units. Again, these are just some of the initial setups. All comes from the factory preset. There will be a few data points there that might get changed from time to time. But if we go back to our status here, date and time is exactly what it is. That's where we set the time and date for the machine. Schedule, if you wanted the chiller to come on at 6 a.m., go off at 6 p.m., that would be in the schedule side. Manual overrides to bypass some of the timers and start the machine. Print is if there's a plug-in printer option you have that you can print the alarm history by using that print button. The service button is an enhanced service mode that allows you to go in and look at various parameters within the chiller to sensor settings, to pressure settings. And then we go back to status, and then probably one of the most valuable buttons here is going to be your system switches. And notice it said unit switches off here, but under system switches, this is where we actually turn system 1 on or system 2 on, or vice versa. 1 off and 2 on, or we can turn both of them on. So right now you can see I've got system 1 is off, and I want to turn that system on. So I'm going to move my arrow over to on. I'm going to say enter there. Then I'm going to go down to system 2, and I'm going to move my arrow over and make it say on. Now I'm going to push the check mark, enter there. Now watch when I go back to my screen, I'm still off on my unit switch, but now I'm off of this switch here. I'm not off of the system switch. So we're going to start the machine up now, and that's just as simple as turning the switch on there. And our status is going to say that our variable speed drive DC bus is pre-charging on circuit 1. The left-hand side is the circuit 1, right-hand is circuit 2. It's getting ready to start circuit 1 compressor. It'll take here maybe about 20 seconds. It'll start up. And while we're looking at that, we can go back to our unit data and notice we're still running 85 degree water. We'll go back to our status. You can see compressor 1 is running, and again, this starts on a variable speed drive, so it starts out real slow, and it's going to just start ramping up faster and faster. The way the machine's going to work is it's going to try to catch the load with the first 100 tons and go from 0 to 100% capacity. When it feels like or calculates that it cannot maintain the load, it's going to slow that compressor down to about 10%, then start both compressors, and they'll work in unison, and they'll go up and load themselves up to full capacity. You can hear the machine starting to go up to wind up. You can always look at the variable speed data here. We're at 58 hertz, 59 hertz. It's commanding it. It's starting to go on. Our condenser fans are coming on now. Then there, our set point, again, it's still at 42 degrees. We go back to unit data. It's at 83, so we've already dropped about 1.5 degrees off our temperature, and we've barely started the machine. We don't have our air handler on yet because we're going to allow the loop to pull down. Anytime you do an installation of these chillers, you want to turn the chiller on and get the entire loop cold. Get it all the way down to set point before you turn your air handler on, so that when you turn the air handler on, the customer gets hit in the face with that nice good cold air. We don't want to start the air handler without having the water cold. When we go back here, you continue to see that our variable speed drive is still ramping up to 82%, and I'm sorry, here, up to 97 hertz, and our unit data is 82 degrees. Okay, the machine's been running for about 10 minutes. You notice now we've got our set point, I raised it up, we've got it at 45 degrees. I'm going to lower that down to 43 degrees, enter, and we'll go back to unit data, and we've got 43 degree leaving, 53 degree return, 10 degree split between the entering and outlet of the chiller at full load is pretty traditional for the design. And the chiller's got the water down, so now it's time to turn the air handlers on. But just to recap, I'm going to go ahead and shut the machine down. And by doing that, I'm not going to turn the switch off. I'm going to go into system switches, and I'm going to turn system 1 to off. Right there, I'm going to push the check mark. And then I'm going to go down to system 2 and turn that one to off and push the check mark. And that's going to lock our machine out. I go back to status, it's going to say system switch is off. And that's the proper way. Now that's the rotors back spinning on the screw compressor. That's the proper way to shut the machine down. So just to recap the keypad, again, there's nothing you can do to push on here that's going to hurt anything. So always go back to your status. The buttons that you're going to be primarily familiar with is your status, which is your home, tells you what the machine's doing. Unit data is where you'll find the chilled water entering and leaving temperature. The data for system 1 and 2 is, again, the technical data of the refrigeration system. VSD is your variable speed drive data. Operating hours and history, we covered that. Set point, a very important one, you're going to push that. Type in whatever set point, and the standard set point is 45 degrees. That's what we've designed all of our equipment to. We push the enter button there. Our programming options, from time to time you'll have a few items that have to be changed in there, such as low ambient cutout or low leaving liquid fluid cutout. And then the date and time, we talked about the time of the day, schedule, manual override, and then again the system switches, very important to start the machine. You're going to come back here, turn that back to on, push the check mark, and that'll start the chiller back up and going. As you can see, very simple to operate, very easy to use. Thank you for your time, and enjoy the new Herc Reynolds 200-ton air-cooled chiller.